for the past 2.5 hours. That goes back from, that would have been what? 7, 8? Yeah. Nah, be all right. Geometric sequence, basically you're looking to divide. What I mean by that is this. If you look at numbers in a sequence, what I mean by looking to divide is, how do I get to the next number? I work backwards. What's 2 divided by 1? What's 6 divided by 2? 24 divided by 6. So basically what you're doing is, in this case, you're multiplying by 2, 3, 4, 5, the next one times 6, times 7, times 8. Is that common multiplier the same every time? No. It's a sequence that you could figure out. It's a sequence that you can figure the pattern out without a big deal. But it's also a sequence that you can't write in terms of geometry. So your answer here would be no, and then you would try to go to the next problem and then do the same thing. Like this. 81, 27, 9, 3, 1. What's happening in time? Divided by 3. You're dividing by 3, or can I write it as multiplying by 1/3? I want to write this as times 1/3. It means the same thing. It means the exact same thing, but your rate value is then going to be 1/3. Bless you. Your value for r in this case would just be 1/3. That's how you distinguish between multiplying and dividing. You can say divide. If I say divide by 3, I might accidentally write 3 as my rate as opposed to 1/3. Okay. If I write 3 as my rate, it means I'm multiplying by 3. If I write it as 1/3, I know I'm multiplying by 1/3. Does that, the difference in that make sense? Again, you're going to have the idea of a first term. You're going to have a rule for an nth term, which gives you a formula. Your first term times r to the n. Geometric is super easy. Well, it helps if you have a degree in it, but yeah. Can you write negative? Yeah, absolutely. Making your first term negative. Like I said before, I'm always going to give you guys the formulas, and it's not that you won't get one. It's just the idea that I won't tell you which one's which. So yesterday, the past couple days, you've had this formula, the sum. When you have your sum, I'm sorry, the sequence, but it's a arithmetic. Sorry, forgot the word. Arithmetic. Think of math and arithmetic. When you learn arithmetic, you learn addition and subtraction. Okay. That's how you can tell the difference if it's going to be arithmetic, because you're adding a common difference. Geometric has a common rate. That's why there's an R in it. So if I run and write this one out like we just did, we knew that our rate was 1/3. Our first term is 81. And your nth rule is something real simple. 81 times 1/3 to the n minus 1. And that's what it looks like. The reason why we have n minus 1 is because if you're looking at your first term, that means your n value is 1. What's 1 minus 1? What's anything to the 0 power? 1. That's how you're able to generate your first term, being 81. And then if you go for the next one, you go on and on and on. Right, that's how that works. That n minus 1 trick allows you to get that one. How's the reception on that one? Is it okay? I know if you're trying to call somebody, you could relate that. Just make sure. I wasn't sure. Because you have it upside down. You got to put the screen to the ear. That's where the. Yeah, there it is. Sorry, Corey. You just kind of staring it off. You're like. I know if you're like imagining ordering a pizza or something. Just like we did the other day, we'll break this into a couple parts. Write the rule for the sequence, then find the 8th term. If I have -8, -12, -18, -27, I got to figure out what my common rate is. Remember, the easiest way to do that is to go second divided by first, third divided by second, fourth divided by third, and so on and so on. What do these all simplify to be? 3/2. Yeah. So your rate is 3/2. Your first term is -8. Together. Which means you just have to know how to press buttons in the calculator. Did you guys remember how to get a fraction bar on your calculator? Y equals good. So all you have to do is, it's a super common one, yeah. -8, so I would type in -8 parentheses alpha y equals 3/2 to the 7th. -2187/16. Huzzah. -2187/16. I did, because I did that one step there. And you can type in 8 - 1 if you want, in case you forget. That's hard sometimes. It's been a long day, I get it. It's okay. Your brain might be fried out by now. Which means, just like we did the other day, you can be given 2 terms. Figure out the first one, and so on. Boy, that looks a lot familiar. I don't know. I think first I was saying that there were a couple questions that might have said graph. Don't ever worry about graphing these. One of the reasons why they ask you to graph with some of this stuff is that you can kind of extrapolate where your stuff is going to, so you kind of get a better idea of what the answer might be. Whenever you see graph, a lot of times I'm going to use my graphing calculator to find n, find those zeros where it crosses over, things like that. That's what I'm going to use my calculator for. I'm not going to graph these by hand. That's just kind of silly. So if the third term is 5 and the ratio is 2, write the rule. What don't you know? You don't know the first term, right? You don't know the first term. So you need to set it up algebraically. We know the rule, a sub n is first term r to the n minus 1. Well, the third term is 5. Don't know the first term, but I know the rate is 2, and 3 minus 1 goes there. I know. Sorry. I will slow down. What's the next one? All right. Nope. What's the first term? Careful, it's 5/4. Yeah. So then you just write it out. Who is it? Come back later, I'm doing the dishes. You know who this is. Wrong movie. What? You're a drummer, right? Yeah, you're a drummer, right? it did that before. I thought you were a drummer. All right. What if you have two terms? Find the rule. We did this last time where you were able to find a shortcut by using slopes. This one's a little bit different. It's not that it's any more difficult, but there's an extra step. Not really, but. If you know that the second term is 45 and the fifth term is negative 1215, that probably means your rate is negative. I don't know. We'll wait and see, but we'll figure this out here. So figure that you've got your rule, your nth term, first term, r to the n minus 1. So your second term is your first term, happens to be 45, which is the first term, just a bit, times the rate to the 2 minus 1. Get that? We're going to substitute into the rule. Same thing over here. The fifth term is negative 1215, which is the first term to the r to the 5 minus 1. You okay with that? Sure. Now, I can rewrite both of them by simplifying my exponents, and I'm going to get 45 is the first term, a sub 1 times r, and the negative 1215 is the first term times r to the 4th. I've got two equations and two variables, so I'm going to want to try to use substitution here. What should I substitute in for? Should I solve one side for the first term, or should I solve for the rate on that with 45? Which one will be cleaner? Get rate by itself. Well, I'm sorry. Divide. I wanted to say divide by the rate, because you want to, if you get the first term, because if you go with the rate, if you get rate by itself, you get 45 over the first term is rate. If I take that, I'd have to do negative 1215 equals 45 over a sub 1 to the 4th power times a sub 1. See where I'm going with that? It gets really, really messy. You want to rewrite it in terms of the first term. Because if you've got first term here, first term there, see how they have the same exponent? You don't have to mess with it. Watch what happens. If you divide out by the rate, you get 45 divided by r is the first term. You okay? Now I can take this here. Okay. Does that make more sense? It's cleaner. Because now you get negative 1215 is 45 over r times r to the 4th. What is r to the 4th over r simplify to be? R to the 3rd. That's the reason why we do it this way, because you always want to get the first term by itself. So you get negative 1215 is 45r cubed. Divide by 45. I don't remember what that is off the top of my head. 27. Negative 27. And the cube root of negative 27 is positive or negative? Negative 3. That means your rate is negative 3. If your rate's negative 3, you got to go back there and figure out your first term. This is a double substitution. Solve one to solve the other. More often than not, the numbers here, guys, are going to wind up nice, really clean. I just did that. Yes, I can. So your rule, first term. What are you heavy signing for? Shift key. Exactly. The algebra here is not difficult. It really, really isn't. If you wind up with some really awful number, that means you goofed up somewhere. You did something silly. More often than not, everything's going to be nice and clean. It should be bad. Does it mean that you couldn't get a complex or a mixed number or a top-heavy fraction for your rate and do that? It's not a big deal. Use your calculator to be fine. Yep, this would be alternating because you got the positive and negatives. That's how your n-1 creates the positive and negatives. That's exactly how it works.
The weirdest version of this comes after we worry about series. The series formula for geometric, the sum of a series, it's actually really easy to use. There's less work when you have to do the problem. You got your first term, then we've got 1 minus the rate to the nth over 1 minus the rate. Unlike the arithmetic one, where we always had to write out the rule for the nth term, you don't need to do that with geometric. Geometric's a little bit easier to use when you're talking about the series. Obviously, again, we can solve for rate, we can solve for n, we can do a couple of things here and there depending upon what info you're given. It's going to be very similar to what we did with arithmetic, 2 parts. Find the sum of the first so many, and how many do you have to add up to make it equal to a certain value. Okay. For example, we'll do this one. We want to find the sum of the first 10 terms of the series and figure out how many you have to add together for it to add up to equal 3906. So this is 2 parts, just like the problems you did the past couple of nights at the very end of the assignment. We have the series 1 plus 5 plus 25 plus 125 plus 625. Now I want to find the sum of the first 10. The sum of 10 of them. If it's 1 to the n, what's 1 to the first? What's 1 squared? What's 1 to the cube? Here we're going. So it's not that. Here, we know that our first term is 1. What's the rate then? 5. So technically the rule here is going to be the nth term will be 1 times 5 to the n minus 1. That's the rule generating that series. But the thing is, you don't need to figure that out. You don't have to write the rule for series. It's just a way of verifying that you have the right rate. Okay. So if I want to find the sum of 10 of them, I know that the sum of 10 will equal the first term, 1 minus rate to the n, over 1 minus the rate. Well, first term is 1. 1 minus 5 to the 10th, over 1 minus 5. And again, I just go right to my calculator and I type that in. Let's see here. So that's alpha y equals fraction. It could be. It's actually a big number. Because if you think about it, if you're looking at your rule, if I have to do this 10 times, I have to figure out, well, what's 5 to the 5th, 5 to the 6th, 5 to the 7th, 5 to the 8th, 5 to the 9th. And then I have to add all of those together. That's why it's a really huge number of 2,441,406. Okay. Even though you're starting out with just 1, 5, 25, 125, 625, then all of a sudden as it grows that much quicker at that rate, that's why you get such a large number. Okay. Okay. The weird one comes with the second part. Just like we did the other day.
when you had to find, when it says find n such that S sub n equals 3906, this means how many numbers in this sequence do I have to add up together to make it equal 3906? How many times do I have to add, 1, 5, 25, 125, 625, whatever's next, whatever's next? How many of those in that sequence would I have to add together? How many times would I have to add those up to get it equal 3906? Well, what we do is this. We know the rule, the generic part, S sub n is first term, 1 minus the rate to the n over 1 minus the rate. We're trying to solve for n. Substitute in everything else. We know that it has to equal 3906. We know our first term in this case is 1. We know our rate is 5. And now I start trying to simplify stuff out. What's going to be 1 times that ugly looking fraction? Just the ugly fraction. Okay. In that ugly fraction, is there anything I can simplify? The bottom, right? The 1 minus 5? What's 1 minus 5? Negative 4. So I'm just going to do this real quick. I don't have to keep moving it around. I know that that has to equal negative 4. How do I undo divide by negative 4? I'm going to multiply both sides by negative 4. When I multiply this side by negative 4, 15, 624? Thank you. And it's negative. Okay. And then this has to equal 1 minus 5 to the n. So I'm going to move the negative 15,624 to the right, and then I'm going to move the negative 5 to the n to the left. And you get this. 5 to the n is 15,625, which means 1 rolls downstairs, goes over your parents, will go over your neighbor's dog. What's fit for a snack? It fits on your back. It's log, log. It's log, it's log. It's big, it's heavy, it's wood. It's log, it's log. It's better than bad, it's good. So it's alpha window thing. So when you're dealing with an exponent that's an unknown, your variable is your exponent. In order to get that to drop, you have to log base. Okay? You have to take the log base 5. The log base 5 of 15,625 is? There you go. Wait, what's the log base 5 of 15,625? 6, very good. Do you want to take a charger home so if you need to use it? Or? No, she's just that smart. Right? Yeah. This is the time where logs come back. Logarithms are one of those things that we've learned a little bit of. When Common Core was first adopted nationally and statewide and stuff, probably about 3 years ago, they completely redid the sequencing of what units were supposed to be taught in the order in which they were supposed to be taught. According to Common Core for Algebra 2 classes, sequences and series was the first unit of the school year. Also, that meant that these problems, which were in the Common Core, were taught about the second week of school, second week of school, which meant I had to ask you guys, 5 to what power is 15,625? And you guys were like, what? So I basically had to teach logarithms the 3rd or 4th day of the school year that year. That was great. I said, hey guys, don't worry about it. We'll relearn this again in about 6 months. But for right now, there's a button. Alpha window 5, I think, is what it was. You guys remember how to get to that? Alpha window 5.
So, did we start second semester with logs? Yeah. Yes, sir. For what? Well, here's the thing. If you're doing y equals, that means you figure out what this is. So you're saying, are you putting 5 to the n equals this? What are you putting in the calculator? 5 to the n? Well, that's fine. And then you're just looking for that. That's fine. That works. But exactly. And these have to be integer values. They have to be integer values. Are you you're just doing 5 to the n and just looking for 15, 6, 25? That's fine. You're doing the same thing. No, it's the same thing. The only thing that stinks about that is if you get a giant number or a really crummy looking number, doing a log base is just quicker. Okay. And go from there. That's why we log. Sir. Five to the n minus. Yes, and you're looking for the 0. Yep. That's no way. That's all the buttons you just press. Just log basic. It's quicker, you know. Oh, speaking of cell phones, there was a picture in the textbook. I know you were so enthralled with the cell phone earlier. This, I don't know how well you can see this. She's got a phone that quite literally is about the size of this, and then got the antenna coming out of it. So remember, if you scale this, here's the antenna, which is about the same size as the phone, which is about the same size as your face. Yes, back in the day, you had phones that were literally this large, and an antenna coming out of them that you would walk around on, paying $12 a minute. I'm at the Ferris wheel. There could be a Ferris wheel inside. The zoo in Madison has a Ferris wheel inside. Or Mall of America. Yeah, we missed Devin today. No, he was on a field trip, I think, today. No, well, sure. We miss you, Devin. You're right. He probably won't. He'll probably look at the homework and say, "Okay, I'll just do it." Angry. Do those. Yeah, because you start realizing I tell a lot of bad stories and jokes. Is the sound? Yeah, the speed is funny when you start messing with the speed on it. So I can talk about things much quicker. What if I start talking backwards and then it would type forward? No, that wouldn't work. If you play it backwards while I'm saying stuff backwards, then it would be in forward. Nope. What? Alpha window 5. Yeah. Yep. So 5 to the n, anything x to the n. What you're doing here is if you log base x, it undoes this. So you just take the log base x of whatever's over here. The biggest mistake you guys are going to make is that when you get to that log base stuff, you're going to get a crappy number because you forgot to add or you forgot a negative. Because this value of n should always be a clean integer. How many do you have to add together? Well, I have to add 6 of them. I can't add 6.2 of them. You know what I'm saying? So if you get a weird decimal, it means you're done. Whatever.